trying, and then I thought, okay, you see here directly behind our processor this both resistors, both are 1K, and when you go along to the western connector where we have our wiring between main and front, you see here on our TX and RX line, again we have 1K resistor, and here as well a 1K resistor. And then when we go over to our front panel, that is again the front panel, you see where this serial data lines come in. You see that we have again here 1K, and once again here 1K and 1K. And I thought, the last step is really to check if we have continuity or not really continuity. We should see between the main processor pin and at least here our front panel CPU pin, we should see 1K, 2K, and then the both resistors on the main panel. So altogether we should see somewhat 4K between the pins right from the main CPU to the front panel CPU, right? So we should see 4K, and that is what I tested, and I then recognized that I have somewhat around 50, 60, 80 kilo ohm on the TX line, so the RX line was just fine. And what I tested as well here, our pull-up resistors, because if you look here to this both resistors, you see that this resistors, if we are following along down here to the voltage regulator, so this is our 5 volt here on the front panel, right? We that was wrong. Once again, panel unit. We are on the panel unit. Yeah, we see that this both are on our finally our pull-up resistors, and yeah, I have tested the 5 volt, which are of course here on this line. You can see this 5 volts as well on finally the main unit. So I tested here, this is again the main unit, and I tested the pull-up voltage here on the TX and on the RX line, so it was simply present, so no problem. And I thought, okay, what's really going on here? I'm testing between the both pins here on the TX line. I really testing 50, 60, 80 or even more resistance, and that was somewhat odd. And then I tested here the R1219, okay, and I've seen that the resistance, and I tested it in circuit, and if you test in circuit you could see lower resistor than this 1K, but you should not see a higher resistor, and it was, so I was wrong, it was not 50K what I tested somewhat 500K, right? And you know, I tested here directly across the resistor, and I have seen this approximately whatever 500K, okay, and I thought, that is really funny, and that was then the point where I added for test purposes here this resistor simply here to the board, right? And I tried to start the radio once again, but no way, the radio didn't start up. So then exactly the same, I double checked here my panel. Yeah, and on the front panel the same problem. There is again a resistor on the board with a high resistance, but it is not open, so that is the odd thing. So normally you would expect that the resistor is really completely open, but it isn't. So again, some ohms higher than it normally should, and therefore I did exactly the same. I put this resistor over the original one, and yeah, so when I had this both resistors finally then connected to this board, both boards, then we definitely have the situation that you see radio is firing up again, and it is working. So that is what happened in between, where I lost finally here my memory card. And well, so what we do now, we of course have to replace the resistors which I have put here on for test purposes with good SMD resistors, and then yeah, we can check if the radio still receives and if all the different functions are given. So okay, let's go ahead with simply adding new resistors to both boards. Okay, so the first what we have to do, of course, we have to take away here our resistor, and yeah, let's start with our first steps here. So that was the test lead. And now, okay, very nice. And already now you can see here the resistor right down here. Okay. And when you watch it, really, you can't see, even here under the microscope, once again, it is this little guy here. Even under the microscope, you do not see that the resistor has any burning marks or what, nothing. So you really can't see it. And yeah, let me take it out, and then let's again test its resistance to know what's going on. Yeah, that is really funny. Okay, so we have already flux here in place, and now we really have to go down here. Try to get our resistor out. Let's see how. Yeah, alright. So it is out. Try that I do not lose it. Yeah, and again you can see here on the board that our resistor is again a bit too large, but as we did it with our last repair, we will fit this resistor in, and therefore let's see. pretty nice. And of course, now we have to do the other side, and we simply place here our resistor onto the test pad. So that is quite okay, so no problem with doing it like this. Okay, where do we need to go? Somewhere here. Very nice. Yeah, what you can see here is that it is sometimes really difficult to find the spot where you need to solder. That is on the PCB. Really, sometimes not really easy. Okay. Hope that we can do now here. Our other side. Yeah. Very nice. That looks pretty good. No problem. Here my iron. Okay, very nice. And he was a little bit out of the field of view. Yeah, sorry. So it is really sometimes here a little bit difficult, but basically I believe you see that we have our new resistor in, and now we will do exactly the same on the front panel unit, and I think I do not really show it twice. So it is finally the same procedure. I will clean now here the area a little bit, and then I go over to our front panel board. Okay, so our both new resistors are in, so everything is just fine. And yeah, so radio is connected to the power supply. And now let's see, where's my button there? Okay, so let's see if it is working. And yeah, wonderful, wonderful. So, and static is there as well. Great. So that is really going in the right direction. I mean, this kind of trouble is really tricky, because you do not really expect to have resistors which are changed their value. I mean, we know that from very old radios from the 30s, 40s, or maybe some from the 50s. We know that some of these old resistors have changed over the time in resistance, but it is a bit new. I mean, this is here the FT7900, which is finally, or still, it is still the latest version. And so you do not really expect that resistors are changing so much in its value that finally the radio don't work any longer. And I mean, why do we have the same problem on both here on the panel board? I mean, down here you have the new resistor as well, and here two resistors in the same line which have changed the value. And you know, I believe that something has happened to the radio, because I cannot believe that it is due to aging, and if so, why two resistors on the same line? But again, I cannot see any burning marks on the resistors, so it is still weird. It is really still weird. So I can tell you it is a very seldom issue. I mean, I've seen so many things, but this is it is a kind of special. Okay, so we are making progress. So front panel is back in housing, and yeah, we have it in the chassis, the main board, and let's test if still is fine, and yes, it looks like very nice. Okay, so the next I want to do is to connect back here our antenna connector to be able to test the radio for TX and of course RX. Okay, so everything is back together for testing, and you already can see it here. So we are receiving, and yeah, that is already awesome, right? And I already see the figures on the tester, so let's go over, and here we have it. So let me switch off the speaker, and you see everything is really nice, so it is working just fine. You can see it here. Yeah, and we are here on an S9 level, and you see our SINAT is just fine, almost 40 dB, which is really good. And so, yeah, it is given here. And of course I have switched over here to 70 centimeter for 33, just a frequency for testing, and we have finally the same result, right? And I just performed here our sensitivity test. You see our 12 dB point is at minus 120, yeah, almost 4, and that is absolutely fine. So let's go back to 2 meter. Let's do exactly the same. And I've done here on 2 meter exactly the same, and you see our 12 dB point is at yeah, approximately the same level, which is definitely fine. We hear, of course, the signal in the noise, so that is no wonder. But we are really fulfilling the specs if we are talking about our RX on both 70 centimeter and 2 meter. Just perfect. Okay, and now we are interested in transmit, so I had to put here my high power power supply to the radio, and yeah, so that is done. We are still on 2 meter, and let's see. Yeah, so radio is set to low, which is approximately 5 watt, which is definitely, or what we are testing here is 4.3, and I'm interested if we see modulation, and yes, we see, so that means modulation is also working great. Okay, so what does it mean? So receive works, transmit works, modulation works. That means everything is fine, and that means radio is back alive. I just want to stop the video here. I have, of course, to do some minor adjustings here and there, and I have to put all the screws here back to the chassis, so I only have the screws in here for final and pre-final, and of course here for the audio chip to have the heat sink. So some little minor things I have to do, but radio is back working, so really that is awesome, as it was really a tricky fault. Again, this resistor thing, it is really a little bit funny, maybe that someone of you may have an idea why this resistor went high resistance. And again, I have tested the resistor. It was approximately 50 kilo ohm. So unbelievable, right? Anyways, tricky fault, not easy to find. But radio is really back working, everything is honky donkey, and let me stop the video here. Thanks for watching, and catch you next time. Bye. Welcome to another episode of TRX Bench. Well, many of you asked for a map update, and here it is. So there are some new tools here in the shop, and yeah, let's go through and let me tell a little bit about my experience with the new tools, and of course with some of the old, to compare it a little bit, so where might be the advantage, yeah, compared to the older one, and well, for what can we use it. So that will be the subject today, so let's go into the video. Okay, so if you have followed my videos in the past, so you may have already recognized that there is a new shelf to simply have here a bit more bench space to organize some of the test equipment a little bit better. So one point was to organize my microscope a little bit better, which is now located down there, and it is easier, much easier to get it out and use it, and therefore I moved my audio tester back to another location, which is now up there, and therefore as you can see, it is now much easier for me to get my microscope out, and today with all the SMD components in modern radios, it is really very often used, and therefore I needed a better access to it, to get it in and to get it out. Then, of course, the next step was to integrate the new radio communication tester, which is more or less modern CMRS, and that will be in the future my main test set. but I will maintain and keep here my CMT, so that will be part of my lab in the future as well, and as well here my HF generator, because the HP is a set which goes up to, let me see if we can see it here, up to 3.2 gigahertz, and additional to that, this HP has an option included which can put out 20 dBm, right? So, and 20 dBm is 100 milliwatt of RF power. So that is a very strong generator, and so therefore this together, of course, with the CMT and with the new CMS will be the main units I need to do here all the radio work. I'm still using my old spectrum analyzer, which is a demand test analyzer, and so that is more or less the backup system for when I really can monitor for using my signal hound. You may know that I'm using my signal hound spectrum analyzer, which is really a nice set, and I really love it because really it is so easy to operate, and it has really a lot of capability in terms of feature set and automatic tests which can be performed without really adjusting all the different steps. So a lot of automatic functions, and if you're following my channel, you've seen that I can display the result here on my main monitor, and that is really then a nice and easy big display. So that is still, or will be still, my main spectrum analyzer, and my spectrum analyzer, which is at least the signal generator, signal analyzer 44, signal analyzer 44B, which is a type which goes from 1 Hertz up to 4.4 gigahertz, so very nice. But I really want to talk a little bit more about my Hacko, so my reverb system. So why it is now a Hacko and not again a Weller. So let me talk a little bit about that. Then saying Hacko, so let us talk a little bit about the fume absorber as well a little bit. So if you've seen my videos, so you may have recognized that I'm now using a more effective fume extractor, and let us talk a little bit about that. And then of course let's talk a little bit about the Rohde & Schwarz CMS, which is more or less one of the latest production of the CMS. You may know that for now you can't buy them new, so Rohde & Schwarz has a CMA, I believe it is, CMA 180, which is the newest and fully digital radio communication service monitor, which is now available on the market. But this CMS are still very popular, and if you have one from the latest production, then it is of course really a nice, let me call it modern radio communication tester. So let's talk about that a little bit. And then let's talk about the Rohde & Schwarz. It is called amplitude controller. So that is the SMDU that1, and that is really not a new unit. So I'm not entirely sure, but I believe the SMDU is now 40 years old or so. I'm not entirely sure, but it is still a very nice unit, which is very, very helpful in your shop, and therefore let's talk a little bit about that unit as well. Okay, so let's start with the Hakko, and you may already see, so that is the Hakko FM203, which is a 2-channel soldering station, and then the hot air rework station, the FR810B. But well, let me first of all talk a little bit about the past to understand a bit better why especially here our new soldering iron together with the station is really handy and is really fulfilling the today's needs. But let's look back a little bit. So when I started with electronics, and that is almost 40 years ago, so you really only needed one soldering iron, right? So you didn't need special tips or even more than one. I mean, alright, so you may have had your preferences for one special tip, maybe something like this, I'm not entirely sure how you call it, or maybe this kind here, or maybe this. So, okay, so anybody was used to have one dedicated tip, but that was not really related to the job you have done, so it was more or less your personal preference, right? So you really could do all your jobs with one tip, so you didn't need to change it, and that was really the fact for more, I don't know, more than 35 years. And then when it starts to really get into SMD work, then a little bit changed, and you ask for another soldering iron. So this here, which is the WSP80 from Weller, and it is still a soldering iron you can buy, and to be honest, it is still really a good soldering iron, so nothing to complain as long we are talking about functionality. So it is really nice. But then, and that is what really changed over the years, you have new challenges. So SMD work is really different to what we did in the past. So therefore, you really needed to have different tips. Of course, no problem. So especially here for the WSP80, a lot of different tips are available. And I was using these different tips for SMD work. So maybe this one, which I used for drag soldering, or this very, very fine tip for SMD work. This, for instance, didn't really worked out very well, because maybe it was too long, and